Okay, new grid. Let's start off right away with learning these divisibility rules. That's what's going to help us as we keep moving forward with greatest common factor and least common multiple, which you'll learn about later in level 1. But for now, I need you to follow along with these video notes, filling in the blanks. So that means you need a pencil out, packet out, ready to go, following along, filling in the blanks. Okay. Now, some of these divisibility rules are going to be things you've heard of before, but there might be a couple new ones in here for you. So I will give you some examples along the way to help you out. But let's get going. So the first one, we're asking if a number is divisible by 1. So we're saying, is it divisible by 1? That word divisible means, can we divide a number by that number? Okay. So when we say divisible by 1, well, all numbers are divisible by 1, right? If you take that number times 1, you're going to get that number. So we can divide any number by 1. So all numbers are divisible by 1. Okay. The next one is it divisible by 2? Well, this one should sound familiar to you, but if a number ends in an even number, so 0, 2, 4, 6, 8, it will be divisible by 2. You can always divide even numbers by 2, and you will end up with a whole number. You won't end up with any remainders. That's what we're talking about. When we talk about a divisibility rule, we're saying, is it divisible so that we don't end up with any remainders or decimals or anything like that. We're only dealing with whole numbers this time. So if it ends in even numbers, so 0, 2, 4, 6, 8, then that would be divisible by 2. So now this one might be new to you. Divisible by 3. That is when you take the sum, so that means you add up all of the digits of the number. If that's divisible by 3, then the original number is divisible by 3. Whoa, I know that's a little hard to understand. So let's try an example. So I've got this number 426. Well, I don't know if it's divisible by 3. It's kind of hard to tell as is. So let's practice the rule. So the rule says if we take the sum of all the digits, and by the way, if you haven't written this example yet, you probably should and do it with me. Okay? So if we take the sum of the digits, so if we take the sum, so add up 4 plus 2 plus 6, and if that number is divisible by 3, then this original number of 426 is divisible by 3. So let's try it. 4 plus 2 is 6. 6 plus 6 is 12. 12 is divisible by 3. I know that because of my multiplication facts. So that must mean 426 is also divisible by 3. And if you want to double check, you can do your long division and check real quick, but it is divisible by 3 because of this rule. You add up the numbers individually in the original number. If that's divisible by 3, then the original number is divisible by 3. Kind of cool. So let's move on to 4. Okay, I'm going to have an example provided for this one too, so go ahead and fill in your blanks and get it written as I talk through it. So the way you can tell if a number is divisible by 4 is if you look at the number formed by the last 2 digits. If that's divisible by 4, then the original number is divisible by 4. So like no matter how big the number is, if you look at the last 2 digits of that number, so like in this case, I have 428. If I look at 28, those last 2 digits, not adding them or anything, just look at how it creates 28. Well, I know 28 is divisible by 4 because 4 times 7 gives you 28. So that means 428 is also divisible by 4. See how I looked at just the last 2 digits? Now, if you only have 2 digits, well, then you could probably count up to 4 or count up by 4s, or you could probably just know that it is divisible by 4. For example, if I just had the number 24, well, that only has 2 digits, so I know that I can figure out if it's divisible by 4 or not. Okay, because I can use my multiplication facts. But this is for like bigger numbers, so we can use that skill. The next one, this one you should be familiar with. If a number is divisible by 5, that means it ends in a 5 or a 0. Real simple, right? Like 5, 10, 15, 20, they all end in 5 or 0. That means it's divisible by 5. Okay? The next one, divisible by 6, this relies on the rules for 2 and 3. If a number is divisible by both, it has to be both 2 and 3. So let's say you've gone through your practices. Hold on one sec. If you've gone through your rules for 2 and 3 and both worked, you've checked off both, then that means it automatically is also divisible by 3. Makes sense because 2 times 3 gives you 6. So if it works for 2 and 3, it also works for 6, but it has to be both of them, not just one. So the rules for 7 and 8 are the same. There are no rules. There are kind of like these really long, complicated rules, but what's the point of that when you could just divide? So if you deal with 7 and 8, the only way to really check that's convenient is just to do our typical long division that we've been doing, which really shouldn't take us that long because we're really just trying to see if it's going to give us a whole number or not. So if you go through the process and you end up with a remainder, then you should know, nope, it's not going to work. Versus if you don't end up with a remainder, then yes, it does work. Okay, so 9 has a similar rule to 3. The only difference is that now you're taking the sum of the digits, still the same, but instead of checking if it's divisible by 3, you're checking that it's divisible by 9. So let's try our example of 426 again. So 4 plus 2 is 6. 6 plus 6 is 12. 12 is not divisible by 9, so that means 426 is also not divisible by 9. Okay? And the last one you should know, if something's divisible by 10, it ends in a 0. Real simple. So I know this is getting to be a little long, but I really want you to see one more example. So if you have some room on your packet off to the side or you just want to follow along, this might be good to do. So let's say we have the number 750, and I want to see what numbers it can be divisible by. So follow along with your rules, and we're going to check them real quick. So I'm going to check 2 first. So to see if 2 works, it has to end in a 0 or an even number. So 0, 2, 4, 6, 8. It does end in a 0, so I'm going to put that on the yes side. It is divisible by 2. So to check for 3, remember it said on your list, if you look, it says sum of digits is divisible by 3. So let's add up these numbers. So 7 plus 5 is 12 plus 0 keeps it at 12. 12 is divisible by 3, so yes, it works. It's divisible by 3. Okay. Now let's try 4. So now I'm going to look at these last 2 digits here. It creates the number 50. Well, I know that 50 is not divisible by 4, so that means 750 is also not divisible by 4. So we're going to put that on the no side. Okay. To check for 5, we're just looking for does it end in a 0 or 5? It does end in a 0, so 5 works. The rule for 6, if you look, is just if it works for both 2 and 3. Well, 2 and 3 are on our yes side, so that means 6 also goes on our yes side. Just going to put it over here. Just make sure we don't think that's a 26. Okay, so for 7 and 8, I'm just going to kind of think in my head for a second. I know 7 fits into 7 one time. So I would have 1 times 7 gives me 7, subtract, get 0, bring down my 5. Well, that wouldn't fit in, so then I'd end up with 0 up here, and so then I end up with 50, and I know 7 doesn't fit into 50 evenly, so 7's not going to work. Okay, I just kind of did some math there. If you want to try it off to the side, double check that I was correct with that, feel free, but I can kind of do that in my head and realize, nope, that's not going to work. I'm going to try 8 real quick too. So 8's not going to fit into 7. It'll fit into 75 9 times. So I'm going to put my 9 up here, kind of imagining my long division here. I've got 72, subtract to get 3, bring down the 0, it's going to give me 30. Well, 8 will not fit into 30, so 8's not going to work. Again, if that was a little too fast for you or you can't picture that, try it off to the side on your own sometime. Okay, going to do 9 real quick. Again, when we add these up, just like we did with 3, we ended up with that number 12. So 7 plus 5 is 12, plus 0 is 12. And so 9 is not, 12 is not divisible by 9, so 9's on the no side. Last one, 10, ends in a 0. Great, 10 works. So 2, 3, 5, 6, 10 all worked. 4, 7, 8, 9 didn't. Okay, now if that was a little too fast for you, please feel free to go back or ask questions, but otherwise you have a little bit of practice to go to, and I don't want to take any more of your time, but I just want to quickly explain that for each number on the left, so you're looking at this number on the left, that was kind of like what we did. So it's kind of like what we did for the 750 right here. Give me one sec to move my thing. There we go. So that's the number on the left, and you're trying to use your rules to see which of these numbers, 2 through 10, we don't have 1 on here because 1 is going to work for all numbers. So we're looking 2 through 10, which numbers will work. So you're going to want to look at your rules and ask yourself what numbers are going to be divisible by it. What I would suggest you start with is your 2s, 5s, and 10s, because those are the rules that you should probably know already, and they're pretty simple. So I would go through and look at, okay, what numbers are all ending in even numbers. If they end in an even number, you know you're going to circle 2. Any number that ends in a 5 or a 0, you're going to circle 5. Any number that ends in a 0, you're going to circle 10. So start easy, and then you can go back and check for 3, 4, 6, 7, 8, 9. Okay, you might need to do some work off to the side on a whiteboard or scratch paper, whatever you prefer. But whatever it is, you want to make sure you're circling all of them. Then you want to check with the answer key first, then get a teacher signature, and move on. Good luck, you can do it.